Definitely in the stage of the PhD, Patrick, where if I had a young protege, I would be like, hey, we should start a podcast. But
yeah,
you already did that, so.
Start another one. Or maybe you need a video podcast.
From ScienceSortOf.com, you're listening to Science Sort of.
Science Sort of. This is episode 254. I'm your host, Ryan, and joining me this week to talk about things that are science, things that are sort of science, and things that wish they were science, it's the return of Patrick.
Hey.
And also back is Charlie.
Pleasure to be here.
It's been 4 whole episodes since we were together, but now we're back together again. It's going to be great. Our theme this week is bear necessities, because in part we're talking about bears and isotopes. 2 of Patrick's favorite things. How do you feel about bears, Patrick?
I didn't know that you were a fan of bears, Patrick.
I don't know.
Should we have gotten Jack on this episode?
I like Stephen Colbert.
Oh, there you go.
Bears are good. I have no problem with bears.
What about big hairy guys?
Even those were okay. So the article I believe you're referring to is a correspondence from Current Biology magazine, which is a journal offshoot of Cell Press, and I don't know how to pronounce any of these guys or ladies' names, but lead author is
Japanese research team.
Yeah, Shoji Naoi, I guess is the first author, and then the last author is Shinsuke Koike, I guess. So. Surely one of those two was the lead researcher. They observed, they noticed that with changing temperatures, they expect plants to respond, right? You expect plants to sort of shift latitudinally or altitudinally in response to warmer temperatures. You either, go further north, or I guess south if you're in the southern hemisphere, or up the mountain to stay cool. And they noticed that cherry trees were doing this, and they were kind of interested in that phenomenon because if you have wind dispersed pollen, no big deal to go uphill. And they specifically they saw that these cherry trees were migrating. I don't know if migrating that's not the right word, but shifting the range uphill. And they said, well, that's interesting because cherry trees don't have wind-dispersed pollen, so it's kind of hard for them to get uphill.
Well, it's not about the pollen, it's about the seeds.
Okay,
right?
Fair enough.
So just to clarify, if you're a plant, you need a way to pollinate and you need a way to disperse your seeds, and you can use wind dispersal for both of those, or you can use animals, or you can just do it yourself. There's lots of different strategies that plants have developed to both pollinate and to spread the result of that pollination.
Yeah, good point. So seed dispersal, not dispersed by wind, and not really easy. Fairly large seeds, kind of hard to disperse. It's a cherry pit. We're all familiar with cherry pits, I hope. So they sort of settled on bears as one of the vectors for seed dispersal. The Asiatic black bear, and they also looked at birds, right? The Japanese marten, but
that's a mammal. It's a type of weasel.
Oh, yeah, my bad. I think I was thinking like purple marten when I glanced at it, which is a bird.
Well, I mean, I have the paper up in front of me, and the figure has a silhouette of a little weasel, and we just covered weasels on the show, so I want to make sure we get the weasels right.
So anyways, they're basically like crawling around on these mountains looking for bear and weasel scat, and when they find cherry seeds in them, they analyze them chemically. They're looking at geochemically to look at the ratio of oxygen isotopes in them, and so oxygen isotopes fractionate or sort themselves differently at different altitudes and latitudes. So they were able to prove that the cherry seeds were coming from trees that were further downhill and being dispersed uphill by these mammals.
Right. So the bears are also going uphill to keep in a cooler zone, right?
Yeah.
So they don't overheat And so it's a nice. It works out well for the cherry trees because their disperser is moving in the direction that they themselves want to move to escape warming temperatures.
Yeah, this is working out pretty well for these cherry trees, but it could all backfire if the thing that disperses you heads uphill before you flower.
You're fruiting while it's coming downhill.
Yeah.
So there are plants that produce fruit in the fall. And so when the bears are coming down the mountain
Not useful.
to stay warm for winter, they're moving the seeds. Because, you can also imagine, like, even without a bear disperser or an animal disperser, if you're not a wind dispersed seed, then your ability to go up against the force of gravity is diminished.
And they also point out that, if the bird dispersers, I guess, are much more likely to be migrating latitudinally rather than altitudinally, and that could be potentially a problem as well. I think the most plants are responding altitudinally.
Right. I mean, one of the reasons they pointed that out is you get a bigger return on investment if you move up altitude because the temperature drops off more quickly on a mountain than it does latitudinally.
Mm-hmm. And I think also the sort of diurnal cycle you've adapted to stays the same as well.
Oh, that's a good point. I hadn't even thought about that.
Let's give a little example of this. So if you've ever been to Hawaii, you can pick whatever climate you want just based on how high up you go up the shield volcanoes. So if you want to be in the tropics, you stay by the beach. If you want to be in California, you go 1,000 feet up. And if you want to be even in a colder climate, then you go further up the side of the mountain. I mean, this is also like well represented in India. When the English took over India, they set up headquarters in Bombay, present-day Mumbai, and then they would always summer up on the Himalayan slope.
Very civilized of them.
Extreme temperatures. Yeah, very civilized of them. They were civilized colonialists performing their atrocities.
But railroads, Charlie, they have railroads.
Yeah, so that's it. I think the Hawaii is best example of humans doing that.
And this is something I think about because I study one of my study systems involves tree sloths, and tree sloths are not the animal that's doing the dispersing of any seeds because they just eat leaves. They don't actually eat any fruit, but they're reliant on the trees being there. And sloths are also highly sensitive to temperature. So I was trying to I came across the study when I was thinking about how are sloths going to manage getting their own trees uphill or up latitude when they themselves can't be the ones dispersing them. So that's going to be a tricky thing for them to pull off.
Yeah, so I mean, I think this paper is pretty cool because I think it's kind of rare that you can sort of really prove the vector for dispersal like this. I guess this is kind of rare in that there's only a couple of mammals that are dispersing these cherry trees. So you've got a really sort of simple system to analyze.
It's great to get some more pin down some more concrete data because the most recent Intergovernmental Panel for Climate Change Adaptation Mitigation Report, the assessment report number 5, I think it came out like a year and a half ago. They had a nice chart that showed how quickly different species can move in kilometers per decade. And then
That's right.
So it's a bar chart, and they had that mapped against different average climate velocities based on different greenhouse gas carbon equivalents in the atmosphere might be present. So they had a 450 parts per million global average, which is what we're basically at now, a 600 parts per million and a 850 parts per million. And they had those different lines for flat areas versus sloped areas. And so it's much easier for species if they're on a slope because they can simply go up. Again, you can get to a different climate more rapidly altitudinally rather than longitudinally. Mm-hmm. But the air bars on these different species, so conifers, angiosperms, spores, and then different types of mammals, etc., the error bars on this graph are absolutely huge. Like they span basically the entire plot.
Right.
So
Well, they're not really error bars. They're just the range, right? So you got the median in the middle, and then the upper and lower
exactly.
limits.
So like for rodents, for example, the maximum
error makes
speed,
it sound like they did something wrong. This is all correct data as far as we can tell.
Well, it says lower bound and upper bound, so it's difficult to know exactly what they mean. But so error bars is a scientific term, and it maybe sounds weird to the layperson because it has the word error in it, but there's no error about it. It's concrete.
It's more just the range of the data. Yeah.
Yeah. So, for example, if they have rodents, they can move somewhere between 3 and 30 or so kilometers per decade. So they can react to climate change that's around 450 to 600 parts per million carbon in the atmosphere. And so the lower range of that might be something really sensitive, like a prairie land rodent, like a prairie dog or something like that. And the upper range of that would be a animal that doesn't care about climate at all, like a rat, for example.
Or something that already lives up in a mountain, like a marmot.
Yeah.
A marmot, the largest of the ground squirrels.
So it's awesome to get some concrete data on specific species for this sort of thing, because this is going to be an important topic the next 200 years or so.
Right, and they also showed that Patrick's flying weasel martin was not as good a disperser as the bears, which makes sense. I mean, it also, matches perfectly within the context of this chart you just sent out, Charlie, where these small-bodied mammals are just, they're not, it really just comes down to stride length, right? Like if bears are going to have a much longer stride than a marten, so it's going to cost them less energy to move a greater distance, right?
Yeah, especially if a bear on a unicycle.
Yeah. I mean, I'm sure, when the marten flies in its bird form, it's probably a different story, but I think they were only looking at the mammal form in this study.
I hate you guys.
If we hadn't just done a whole topic about weasels, I wouldn't be harping on it so much. But I couldn't help myself.
Well, you might not have caught it if you hadn't just done a whole thing on weasels, which ultimately is a good thing that you did.
I think I would have. I mean, I'm gonna remember a marten. It's a pretty cute marten, as martens go.
Although it looks like it has no legs on this chart in the paper, or no hind legs rather.
Well, what's that? Bergman's rule or Cope's rule?
Yeah.
Which was the rule where the legs get shorter?
As you move northward, you have less legs.
Yeah, that's a thing, right?
Like dwarves?
No. Like so Charlie, in macroecology, there's all these like different rules. So general trends that certain types of animals follow based on geography or whatever other thing. So there's Bergman's rule, which I think is just body size.
Yeah.
Right. Bergman's rule based.
Go ahead.
Yeah. Bergman's rule is just as you move up in latitude, you increase in mass.
If you're a mammal.
If you're a mammal, well, there's not that many tropical or Arctic lizards.
No, but there are some, and they get smaller. I mean, not Arctic, but in general, you get smaller as you. I think,
you just want to increase your volume to a spatial area ratio. And
in that same vein, I looked it up because I couldn't remember it. There's Allen's rule, which is the
extremities.
That extremities, minimize in extreme environments. So shorter limbs and broader trunks in endotherms. So in warm-blooded animals. Polar bears compared to like grizzly bears or any other more southerly species of bears. Foxes, Arctic foxes, definitely show this trend pretty well. They have shorter, stouter limbs than more temperate or are there tropical foxes?
I don't know. But snowshoe hares have smaller ears.
Yeah. Rabbits and hares are another good one. So it's these kind of generally broadly applicable rules that we see in the ecology and morphology of species across the globe.
Yeah.
So
you basically just want to either conserve heat or radiate heat. And if you're a massive mammal in the tropics, then you have huge ears to radiate heat.
And less fur, right?
Yeah.
I mean, none of those giant
like humans,
elephants and rhinos, and like humans, yeah.
And if you're a hairy lion, then you just lay on the ground all day long and pant. Yeah. Wait for night.
Yeah, they do spend most of their day just kind of lounging about, don't they?
Yeah.
I mean, humans count as megafauna, right, Patrick?
Yeah. Well, yeah, I guess so. I mean, especially these days, especially Americans.
Americans. Yeah. That's what makes sloths so weird, is that they're this tropical animal that's covered in a dense mat of fur.
It does make them weird.
Yeah, well, it's one of the many things that continue to make sloths the weirdest. But we might not have to worry about them for long if their trees can't move fast enough. Hooray!
Another problem solved.
One,
Thanks to technology.
yeah. 2 more genera in the bank for paleontology. Take that, modern biologists.
Yeah. You're becoming less relevant by the day.
Yeah, I also noticed that, like, on the chart that you sent Charlie, which we'll post in the show notes for this episode, the carnivorous mammals was represented by the silhouette of a cheetah, which, again, a mammal we probably won't have to worry about for much longer. Sorry, cheetah lovers. Whereas
that is the problem. There's not enough cheetah lovers.
The split-hoofed mammals are represented by a moose, and every single moose can go die for all I care. I'm mad at mooses right now. So,
okay. How does that Monty Python thing go? My sister hit a moose once, or something like that. A moose bit my sister once.
I had a moose try to hit me.
Yeah,
that's basically my life.
In a nutshell,
it's just fighting off mooses. Yeah.
Yeah. Well, that's what happens if you live in Wyoming, I think.
Yeah, I know. I've seen plenty of moose before, but I haven't had too many negative encounters except for the one. But it turns out one is all it takes to change your opinion on mooses drastically. Or is it just moose? I think moose is one of those words that is its own plural. Did we decide on that? I think we decided on that.
Like data is becoming... Oh, I heard the word datums used.
Yeah, I use datums all the time to annoy my advisor. It's super fun.
Well, this was in the context of geography and different projections. So you use a datum to like basically ground the projection you're using. So I guess datums kind of make sense, but still the plural of datum is data.
Right.
But nobody would have known what he meant if he had said data.
No, that's a good point. That's an interest. Yeah, I hadn't thought about it from a cartography perspective. Huh, cool. Yeah, all those, I mean, and like people never say stadia. They always just say stadiums.
Yeah.
Right? Gymnasia. Yeah. They just say gymnasiums or gyms. Mm-hmm. So there are Latinate ending words out there that technically probably should be pluralized with an A instead of an S, but depending on the context, it seems like scientists are good about it generally. Whereas if it's not in a scientific context, we tend to just pluralize it.
I've never
like
understood
any other
why they think that these things are like hard and fast and immutable. I mean, Latin was always in motion too, just as English was. So, I mean, I'm sure there are people mispronouncing Latin all the time back in the day. And we may have, the original Latin from different authors, and maybe they were grammatically idiotic. And so we're continuing to use poor grammar from a Latin.
But I think there's something to be said for, at least when you're trying to do science, when you're trying to create this knowledge base that spans generations, to come up with some consistent rules you try to hold to, just for clarity's sake.
I think that is why we chose Latin, because it is a dead language and it wasn't going to evolve anymore.
Yeah, it's relatively immutable. Yeah,
but still, we're essentially stadium, for all intents and purposes, is an English word now, and I mean, if you're speaking English and using it, I know it's used in other languages as well, but for an English,
like the original Greek from which it came, Patrick.
Sure.
Because the length of the original Olympic races, the unit of the race was called a stadia, and so the places built up, the stands built around the stadia length that the runners were running were called the stadium. History of English podcast. Learning all the words.
See? It wasn't the history of Latin.
You think that's boring?
Yeah.
The podcast starts with like Proto-Indo-European, so then it moves through the Greek and into the Latin.
No, that sounds fascinating. Talking about stadiums and stadia is boring.
But Charlie, sports just happened yesterday.
That was pretty cool.
It was a good game.
I'm a little worried about it, though.
Check off the bingo card for things you wouldn't expect to hear Ryan ever say on the show.
No, that was an epic game with the rain delay and everything. I was having fun.
Well, and a home run in the first at bat. That's crazy. That was awesome.
Yeah.
You know what else they do inside stadiums, Patrick?
Not after the 7th inning.
Well, we're still in, I think we're going to call this the 3rd inning of the show. So what would still be available in the stadium is beer. So let's move over to the next segment and talk about that.
bear that was a bear, all black and brown and covered in hair. 3 boys a girl and a dancing bear. Their dances spun right to the fair. How sweet she was and pure and fair, the maid with honey up in her hair. He smelled her on the summer air, the maid with honey up in her hair. With a hairy bear, I call the night, but you're a bear, all black and brown and covered in hair. From there to here, from here to there, all black and brown and covered in hair. You smell that girl, the summer air, the bear, the maiden fair.
Well, it would not be an episode of Science Sort of if we didn't also talk about what we are drinking. Let's go from east to west. Patrick, you're up.
Okay, I might have finally got a beer you haven't had, but this always ends in failure.
Hovering the hands over the keyboard. I'm ready.
Okay, so this is a beer.
I've had that. I've had those before.
Okay, from Yee-Haw Brewing Company,
Okay.
Johnson City, Tennessee.
Yeah, you might have me.
This is an 80, which is a Scottish style ale. And
Do either of you know why Scottish style beers often use the number 80?
I do not. Do you know, or you're
No,
genuinely
I
curious?
don't. I feel like I've heard that before. Because there's a beer here in Laramie. I have not had that beer, Patrick, by the way. Congratulations.
Oh, thank you.
But there's another beer in Laramie that's a Scottish ale that's called a heavy 80 Scottish ale. So I just don't know if they're like some...
I just Googled it. It says 80 shillings, so
yeah.
maybe that was...
So maybe a ale in Scotland cost 80 shillings back in the day?
Yeah, I don't know.
Beer.
Oh, it was based on
The weight of
alcohol,
something?
alcohol content.
Oh, so, okay. So
An 80 is a wee heavy, so that's up to 5.5. If it's above 60, it's above 6%, it's a 90. And that's just a straight shilling.
Yeah. Yeah,
So,
because
so it's a
Odell also has
percentage
a
of, so like they said a shilling would be your 6% standard beer. And if you're getting something less than that, then they just kind of fraction percent signed it.
Right, yeah. So Wikipedia actually has a page on beer in Scotland, and one of it is shilling categories.
Yeah.
So you have
So
your
this
light,
is-
your heavy, your export, and your wee heavy.
So this is a 5%. So I guess 80 is correct.
Cool. Wow. I'm glad to have learned that.
Nice.
Good job, Patrick.
Thank you.
Now we can annoy our bartenders.
I would like the 80 shilling, but actually I'm trying to make it sessionable, so can you add enough water to make it a 60, please?
Yeah, do you got a 60 IPA?
If it's Dogfish Head, they do.
Yeah.
All right, I'm up next as the next most westerly person. Also, by the way, I had to convert a bunch of UTM coordinates into latitude longitude, and that is an annoying process.
Can be, for sure.
Why do we still have UTMs? What is the point?
Well, because I think they make a lot more sense locally.
Not to me. I mean, it wouldn't have been so hard if it was easy to find a way to convert them, but then you gotta find your zone.
Yep.
And finding the zone was annoying, and then there's you got to make sure you're using the NAD 83 or the NAD 27. It's just too much. Cut it out. I just wanted latitude longitude.
Oh yeah, did you see that new map that you can fold into? That guy has a map that's has all the land masses and oceans much more accurate relative to each other. So accurate that you can
it's the
actually
one that's
origami it into a sphere.
Oh, cool.
wow,
I
that's
did
a
not
great.
see that.
I saw some people posting about some wacky map projection that kind of looked like it was hovering off kilter over the North Pole a little bit.
Yeah, I think it's the same deal.
Isn't the UTM? It's for troops, right? So you can know how many meters you need to move.
Well, I don't know. Yeah,
You can be like, I need to go 6,500 meters.
it is in meters. Yeah.
to attack a target or something.
Well, the UTM stands for Universal Transverse Mercator.
Yeah.
That's what the M is for there.
It's basically in like your latitude, longitude, but then the decimal point is converted to meters. So it's good for like military maps.
Well, I had to convert a bunch of it back to latitude, longitude.
Pre-GPS stuff. Now with GPS, yeah, of course it's stupid.
Well, I also need to compare. I need to compare latitudinal differences over a very large range of latitudes and longitudes, so the hyperlocal accuracy of UTM wouldn't have been easy to make the comparisons for.
Yeah, it has its uses, and that is not one of them.
So, I mean, I think statistically, I was doing the right thing, Patrick.
Yeah,
I know you're okay. Got to get it into R somehow.
Just tell your computer to do what you want it to do, and it'll do it.
I try to every day, and somehow the only thing that comes out is this podcast. I'm having a beer.
Okay, I forgot about that, but yeah, go ahead.
I almost didn't have a beer, but then I decided to have a beer. I had other options. This is an Árcáná. It's a collaboration beer between Stillwater Artisanal Ales and Hoften Dormal. And it's a farmhouse stout aged in red wine barrels. But it's only a 12 ounce, so it shouldn't knock me out too much. But yeah, it's got a little bit of the kind of red wine tart sourness to
That's
it,
cool.
layered on top of the stout.
What varietal of red wine?
They don't. They should though, shouldn't they?
Yeah, shame on them.
Is there a Belgian blend of red wine that they could have used?
I had a white IPA aged in Pinot barrels recently.
That sounds nice.
It's pretty nice. It was pretty. I realized I should only have one because you would get hungover if you had too many of them.
I mean, I don't love white IPAs in general.
Yeah,
because they're usually it's basically like a wit ale lager, but with the amount of hops
there was a
you
lot
would put in
going
an
on with
IPA.
this beer. It was hops, wheat, and Pinot.
That's strange.
It was pink colored too.
I mean, that's kind of adorable.
I'm a confident middle-aged man, so I was fine with that.
There's also that pink spruce gin that Rogue makes. That's pretty good. It's a gin aged in Pinot Noir barrels because it's Oregon and they have to play true to type.
They probably also have a lot of those lying around in Oregon.
No shortage.
But they also put spruce in the gin just to make it even more Oregonian.
Gotcha.
So, so I'm having a very magically inclined beer for our science podcast.
Nice.
Fantastic.
What about you, Charles?
Well, here in Washington State, it's fresh hop season. It's hop harvest time. So I'm going with a Bale Breaker Topcutter. And so it's a fresh hop IPA. And Bale Breaker is a brewery based on property near Yakima where many hops are grown. So they're one of the few breweries where they kind of have the winery thing going on where they brew where the hops are being grown. So,
have you been out there? Is it like super picturesque?
Yeah, it's very picturesque. And so, yeah, a Topcutter is the machine they use to harvest the hops from the hop plant, and the hops at the top are the most choice.
So this is like a reserve.
Yeah, if people are familiar with
wine terms,
a plant that's a cousin of the hop plant, they would know that you would pick the buds from the top as well. And so it's a good beer. So this one it's mainly Simcoe and Citra hops.
Huh.
Nice.
They also have a bottom cutter, but it's their Imperial IPA, and it's too heavy for me. I don't like drinking it.
But you like Imperial IPAs in general.
I do, but I just they're more something to have at the very end of the night.
Yeah.
And I'm on the West Coast, so it's 4 p.m. here. I should not have an Imperial IPA.
So
I was just in Salt Lake City for a meeting, and everything on tap in the state of Utah has to be 4% or under, which is actually kind of nice at a meeting. It was easier to wake up most mornings.
Yeah.
Than other meetings I've been to. So, we went to a brewery that had like a lot of variety of 4% beers.
In a lot of places, you have to order food if you order.
No, I don't think that's not a rule anymore.
That is some places.
Okay.
I was there.
I went to plenty of places and just drank beer.
I don't know exactly what the rules are, but it was It was a thing in a couple places I went within the last 12 months in Utah.
Well, we have at least 3 former guests of the show that live in the Salt Lake City area, so I'm sure they will write in with corrections.
Awesome.
Yeah, when my sister lived there, she just had to she'd have to join a drinking club or something, like a private party thing.
There's also a weird thing where
buy like an annual membership or something.
There's also a weird thing where kids can't see a bartender making a drink or aren't supposed to see. So like a lot of the bars, they just card, like at a certain point in the night, they just card everyone who comes in so nobody under 21 gets in. But the hotel bar, where it's just in the lobby, so anyone can be walking through, they wouldn't let you actually just walk up to the bar and order a drink. You had to sit down, wait 30 to 40 minutes before anyone paid attention to you, and then you were able to order a drink. So, weird rules. I think time for the next segment. I guess speaking of places we might want to move to soon, space. Coming up next.
Outer space?
Yeah, so some scientists, if you can believe it, found what they're calling the first observation of a star's snow line. And I assumed, Charlie, you just knew what that meant. It wasn't immediately obvious to me. Yeah, so why don't you walk us through what they were looking for, and then maybe we can talk a little bit about how they found it.
All right, so there are 100 some odd elements in the universe, and they can combine together to make molecules. And all these molecules have an equation of state. So what does that mean? It means depending on the pressure and temperature, they will either be a gas, a liquid, or a solid.
Or plasma.
You might be familiar with water that does that on this planet because we live in a pressure and temperature regime on Earth that water can exist in all 3 phases. So if you look at the solar system, the pressure is fairly uniform because you're in the vacuum of space, but the temperature, now might be a stretch for you to think about, but the temperature gets hotter the closer you are to the sun. And the further away from you are from the sun, the colder it is. And so at any radial point from the sun, different molecules will either be...
That's why when you go uphill, it gets colder.
Yeah. These molecules,
you're going closer to the sun, Patrick.
Yeah, when you climb out of the gravitational potential well. Exactly right. Different molecules will either be a solid, liquid, or gas. Because the pressure's so low, they mostly just fall in the regime of solid or gas.
Okay, that makes sense. Yep.
That's about it. And so when the solar system was forming, when the planets were forming, there was this big disk of gas that was coalescing. And the further you were from the sun, different molecules would fall out of their gas phase into a solid phase. As soon as they could do that, they could start glomming together gravitationally. And then you could form rocky bodies and planetoids, planetesimals, planetoids, and eventually planets. Now, the thing that really got that coalescing and accretion kicked into gear was as soon as water could drop out of the gas phase into the solid phase, because water likes itself. Water is very narcissistic, and it has this thing called hydrogen bonding, so the water gloms together. And so as soon as water falls out of the gas phase and can be in the solid phase, then it sticks together rapidly and really, really speeds up that accretional process. And so as soon as that happens at a distance from the sun, you start forming things like gas giants. Because the rocks kind of fall together because of gravity, but then once the water gets into play, the planets grow big very rapidly. And as soon as they're big enough to attract gas species gravitationally, then they form gas giants.
So in theory, there's plenty of water on all those in all the gas giants?
Oh yeah.
Or is it no longer? There's just plenty of oxygen and hydrogen. Does it stay water, or does it turn into other molecules?
Some of it disassociates, and so near the surface or near the top of the atmosphere, the gas giants, the cosmic radiation will break apart, disassociate the water into hydrogen and
just
oxygen.
lose hydrogen.
But then once you get deep enough down and protected from magnetic fields, then there will be water, most likely still in the gas phase, and some in the liquid phase. And then once you get deep enough, then you may find water in the ice phase too. But then once you get really deep, the pressures are such that the water will disassociate again, and you'll have like metallic hydrogen.
Cool.
Yeah. So in this recent paper published in the journal Nature this July, some scientists, including Lucas Cezia, discovered a snow line from a star 1,350 light years from Earth. And this was a really exciting discovery because this is one of those things where, like, of course we know it probably happens. It's fairly straightforward thermodynamics. And we can see evidence of this in our own solar system because all of a sudden at about 3 AU or so, that's 3 astronomical units, which is the distance between the Earth and the sun, then water will freeze out from the gas into ice. And once you get beyond that point, you start getting gas giants, including Jupiter, Saturn, Neptune, etc. So we knew that these snow lines probably existed. We just haven't caught them in the act yet until very recently. So the star is V883 Orionis, and we were able to see the snow line of this very young protostellar disk because it was far enough away from the star that we could actually see it. We've seen other protostellar disks, but we can't see the snow line because it's so close to the star that the brightness from the star completely blinds our ability to see the snow line. This one we were actually able to see because a bunch of material happens to be falling into the star just now as we're looking at it. And that has really invigorated its nuclear furnace. And so the snow line got pushed out way further out than it normally would be for a star of that mass. And so we can see this big disk of bright material far away from the star. So we know at that point there's a bunch of water reflecting the light from the star at that point. Ice crystals, basically. So it's pretty exciting.
That's cool. And I mean, is an observation like this, it seems like with planet hunting, we got better and better at finding big planets, and that helped us get better and better at finding small planets. So is this the same sort of thing where, like, finding a snow line or an ice line that's far away from the star might help us know what to look for closer in? Yeah,
I think so. That would be a reasonable deduction to make. So if we have a snow line far enough out from the star, then that would allow for the formation of more rocky bodies rather than gas giants within that snow line. And those would potentially be habitable because if they're able to form far enough from the star that they won't just be completely cooked by the star, then it could be a planet like ours where water could exist in all 3 phases.
Very cool. So do we know where our star's snow line is?
Yeah, ours is somewhere between 2.9 and like 3.1 astronomical units. And so at that point, so it's beyond Mars. Mars is what, 1.5 or 2.5? I forget. It's been a couple years.
Since you went to Mars?
Since I was a planetary scientist.
Yeah.
It's weird how you can remember all this stuff and then you forget.
I know. It's almost like it's not that useful in everyday life.
Okay, so Mars is at 1.5. So I wasn't terrible. I said 1.5 or 2.5, I think 1.5. So yeah, an asteroid belt is around 2.5, and then Jupiter's at 5. And Jupiter was so massive, it cleared everything up into the snow line.
Okay.
And didn't allow, the asteroid belt should have been another planet, but it wasn't able to form because the tidal forces exerted from Jupiter prevented its formation.
So the asteroid belt making a barrier between our snow line and water line is just coincidental because Jupiter formed. It's not a consequence of this snow line.
I mean, it's all interrelated, right? So So there's two competing forces for the formation of gas giants. The further away you get from the sun, then you can allow water to be in ice form, and that's really conducive to planet formation. But on the other hand, the further away from you are from the sun, the density of material decreases.
Okay.
And so there's these two competing effects. Can you form ice, and is there enough stuff around to form a giant planet? And Jupiter was right in that sweet spot, right where ice could start to form, and there's tons of material. And that's why Jupiter won the sumo contest.
Yeah, I was going to say, it may have won, but it didn't win our hearts and minds, because Charlie likes Mars better.
Of course.
And Charlie likes Earth best of all.
I do like Earth best of all.
Take that, Jovian gas giant.
Yeah, Earth's beautiful.
Nothing Charlie admires more than a planet with all three phases of water.
He does like Earth a lot.
Not constantly at the triple
does
point.
for you.
So anything left to say other than good job, scientists, for finding the water line?
Yeah. But I guess the only last thing to say is this particular star, because it's a very young star and it's got a very irregular nuclear furnace right now, it wouldn't be a good place to look for life. But it still informs us on what would make a good solar system for life.
This may be a totally that's an awesome point to wrap up on, but now I'm legitimately curious. So the star is 1,350 light years away, which means that we're seeing it as it would have looked in about 650 BC. Mm-hmm. Would it look... Is this star dramatically different now, or is that such a short period of time in stellar evolution that it doesn't matter?
It seems like it'd be a really short amount of time.
Okay.
And whatever material is falling in to make this crazy furnace heat up right now is probably still occurring. Unless it was a very catastrophic event, like a potential, there's certainly ideas in the formation of our solar system of other massive giant planets that crashed into the sun. And so it could have been like a Jupiter hitting the sun, and that would certainly piss off the nuclear fires.
Oh, all right, cool.
The gods of
Speaking of
nuclear
pissing
fire.
people off, what about our final segment where we deal with listener feedback?
Nah, we do pretty well by them.
they treat us with kid gloves, and we appreciate it.
Or at least if they don't like us, they can't be bothered.
They do
to
mostly
tell
treat
us.
us with kid gloves. Yeah, it's good.
Yeah.
I think they can tell that we have sensitive artistic souls, even for scientists. Well, let's see what they had to say this week over in our final segment, the PaleoPOW.
Standing by the gray ice water, out in the wind, above the ground, out in the weather. You had yourself a crazy lover, becoming frost, trying hard to forget her. You got a job up in Alaska to save what they can repay, 'cause there ain't nowhere to spend it.
The PaleoPOW is a segment of the show where we deal with feedback from you, the listener, the person listening to this show right now. I've got a bit of a repeat, but it's a repeat worth repeating, and that's because we got another generous donation from John Pohl. I say his last name because he was a former guest of the show, here to talk to us about poop. So you definitely want to go check out that episode.
If you listen to it backwards, it's still poop.
That's true. Wow. Really makes you think. And I had the great delight to get to catch up with John and his wife in Salt Lake City last week when I was there for my meeting. I also got to hang out with Daphne, other former guest of the show. So we just not all at the same time, but John and his wife were nice enough to take me out for dinner and drinks, and more than 4% drinks too. So that was great. And he's also, donated semi-recently, and we haven't thanked him specifically for that donation. So thanks, John, for feeding me, for giving me drinks, and for contributing to the show. That's like, you're my best friend. What more could I want?
Yeah, he's taking care of us, and you especially. That's good.
Yeah. So thank you, John.
Thanks, John.
Episode 202 is his episode, if you are curious. if you scroll through our beautiful new website's show notes, where I've been going through and making all the images the same aspect ratio so it scrolls beautifully, just look for the poop. That's where it is. Well, I think, Patrick, we're going to bracket to the 2 shorter ones with your somewhat lengthier PaleoPOW this week.
So I got a great email from Jon B, but it is lengthy. I'm going to do my best to try to follow the logic and summarize a little bit. So this basically dates back to a show we did back in September, in the podcast Feedback. Somebody asked about red hair in humans, and we tangentially started talking about the lack of green fur in mammals. It turns out John's been interested about that very topic. He's been thinking about it deeply. So he gives the example of tigers and saying, "What the heck? These guys are bright orange. That can't be useful." He's like, "Yeah, they have these black stripes to help them blend in. So that's nice." But he brings up the fact that most vertebrates, and I think by most vertebrates he pretty much means reptiles, have tetrachromatic vision, reptiles including birds. They have sensors for red, green, blue, and ultraviolet light. But most mammals don't have that. They can really only see blue and either a red or green color, sort of the colorblind version of blue and red, I guess. So he says an early common ancestor of mammals, lost this gene. So most mammals are red-green colorblind. Primates got their red vision back, probably so they could find fruit or ripe fruit
and mates.
Yeah.
You think the mates came later after the fruit?
Maybe. I don't know.
Because you got those red chimp butts and the lip engorgement.
Yeah, and flushing cheeks and of both varieties.
Yeah. Yep. Oh, I'm not mature enough.
Okay, so he says he figures that like tigers and rabbits and lots of other mammals would be better off if they could shift their sort of reddish brown. I guess reddish brown means round. That's my own invention. Reddish brown fur to green. So wouldn't that be great? Then you'd be less visible to hawks and reptiles, I suppose, if you did that. But he postulates that they can't apply sexual selection to maintain sort of green fur because most mammals can't see green. However, I'm not sure that really makes much difference. I think if you've got evolutionary pressure from getting eaten,
predation,
the sexual selection thing shouldn't be such a big deal. But that's an idea, and I have no direct evidence that that's not the case. So it's worth thinking about. Let's see, where's he going from here? Offspring probably they wouldn't do as well. Oh, he said they would be selected against sexual selection would go against these green things if they happen to occur. And maybe that's true, but if you can't tell the difference in red and green, I don't see why that would be. And he says, sloths, they've got this symbiotic relationship with algae, so they have kind of greenish fur. They can't help it.
They have greenish, and I mean, I'll clarify here. They have greenish fur some of the time during part of the year on a part of their body. Yeah. It's not like, I think there's a lot of misconceptions about just how green sloths are, and I'll just go ahead and say, they're basically green on their neck and shoulders, maybe going down onto the haunches a little bit, and it's mostly prevalent during wet seasons and kind of doesn't really show up as clearly in the dry season. So it's not this totally green sloth crawling around the trees.
So basically, to sum up, he thinks that the lack of green fur might be sexually selected against in mammals. I feel like maybe I'm butchering this because they...
Yeah, I'm not sure John's going to be happy with your reading of his email. Oh, that's funny.
Yeah. So I feel like I'm missing.
He's basically saying that, if mammal, I think he's saying is if mammals could see green, then the likelihood of evolving green fur would increase because you would be able to select for it on purpose, and it would theoretically provide an advantage for prey to avoid being seen by predators that can't see green. But he's also talking about how much of an advantage it would be for predators to evolve to see green. So it seems like everyone would be better if they could see green, but for some reason evolution hasn't bothered.
Mm-hmm. Well, I think
I'm not sure where
because mammals are mostly nocturnal.
Or at least, yeah, we started off as a nocturnal, possibly subterranean group, right? So those are two environments where having a full range of color vision isn't as helpful as maybe being able to sense motion really well.
Yeah. Or smell really well, which is a thing that most mammals do, but humans don't really do that well.
We smell ethanol really well.
Yeah.
Better than most other mammals. That's our advantage.
That's our
Silicon Valley's secret advantage. Yeah.
So finally, he sums up with kind of a humorous point about talking about red-colored fur in humans. He says we neglected to point out that gingers have no souls. It's not clear why those two mutations are linked, but he has it on good authority that they are.
That's kind of like the first episode of Mad Men when John Derber wants to advertise the cigarettes with like, it's toasted. And it's like, well, isn't everybody else's tobacco toasted? No, theirs will give you cancer. Ours is toasted.
Right.
And it's like, I mean, if you believe in nothing and have, then like many scientists I know do, then nobody has a soul. So saying gingers have no soul, you're needlessly splitting us into groups. We're all soulless monsters. It's fine.
Yeah. It's not easy being green. That's the moral of this story.
It seems like you struggled with this.
I did, man. I sort of thought I had some logic going for a little while, but then I lost it. Yeah.
Doesn't the sun's spectrum peak in the green wavelength?
I think that's why chlorophyll evolved to be green, right? To maximize absorption for photosynthetic purposes.
I think what John's mainly asking is, the whole world's green, like the whole jungle's green. Why are tigers orange? It doesn't make any sense.
It's green when the sun's out, but then the sun goes away for literally half the day, Charlie. Like half the day is night. And
I wouldn't know. I'm asleep.
Well, I think part of the point is that most mammalian predators are hunting other mammals, and those prey can't see green, so it wouldn't make any difference if those predators were green or not. Right.
Because they'd still just look brown to the predator.
Yeah.
Are there any green mammals?
No.
I mean, people say the sloth.
I think that's the other thing. I think it's hard to make green for us because we're all like, what is that? Melatonin or melanin or something based?
Those are definitely two things.
Yeah, one of them makes you sleepy, and one of them
makes you tan.
Makes your hair different.
Yeah. Melatonin makes you sleepy. And melanin makes you tan.
Yes.
Also, it seems that being kind of a tawny, orangish, reddish color is probably the ancestral state for most cats. It's really the stripes that are providing the camouflage for the tiger, not the orange color, right?
Sure. Yeah.
Because the stripes are breaking up the visual pattern of the scenery within which it's hunting. Yeah. But like lots of cats have, they may blend into their surroundings because the surroundings happen to be that color. So if you think about like mountain lions have that kind of tannish color, and when they're in, the American Southwest, it's like, oh, look how well camouflaged they are. But those are also a cat that lives in jungles. So, and jaguars, they're not as brightly orangish as a tiger, but they're still
the underbrush of jungles actually aren't green at all.
So I think another point here is that most mammals just don't see that well at all, not to mention in three colors. So I think the hiding that a lot of predators do is based on other senses than just visualness.
Did you guys hear about that woman in Wales like 2 months ago? She does have like more.
Well, she can see ultraviolet.
Yeah, she has more cones than the normal person has.
I mean, that's really interesting.
Yeah,
I hadn't heard about that.
Into the ultraviolet or the infrared. I forget which one. I think it's
ultraviolet indigo or whatever it is.
Yeah, she has a whole nother receptor that most people don't have.
Interesting.
And so it took like the inbreeding in whales to make that happen.
But I think Patrick's right where these large cats, I mean, we're talking about a pretty big animal, but if you've ever spent any time in the tropics where there are large cats around, you'll never see one, A, because they exist in relatively low population densities, but B, because if they don't want you to see them, you will never see them. Like, it's all about hiding and not being seen because they don't move when they know that they're being watched or something like that. I mean, they're just really good at hiding generally, and the color has nothing to do with it.
They know how to hide and not be nervous about it.
Yeah, there's a quiet confidence in their hiding.
Their normal chill state is hiding, whereas if I'm hiding, my heart's racing.
Like, people ask me, with all the time I've spent in Costa Rica and Panama, have you ever seen a jaguar? And I'm like, no, but I'm sure they've seen me. Like, because they're there, and they're probably watching and checking me out. And that's,
like, if I'm hiding, I'm like, don't sneeze, and then I sneeze.
But that's the thing about cats in particular, that the majority of cats are ambush predators, right? They're waiting to get close enough that they can, within one or two lunges, reach the prey item. They're not like dogs, which are more pursuit predators, where it's like, let's run this thing to exhaustion. It doesn't matter if it sees us. We're still going to just pursue it. So it's, it's all just different strategies. And the other thing that people often forget about large cats, especially the solitary ones, so excluding lions, which, hunt in groups, their hunting success is pathetic. I mean, we're talking like 25-30% success rate.
Yeah.
So a lot of times they are seen, or the animal does get away.
Yeah, and they're so bad at it, they're not even like that disappointed when it doesn't work out. They're just like, oh yeah.
Because that's the norm. It's the rare event is when they actually catch something.
I wasn't even trying, and then they just kind of like walk off slowly in a different direction.
Right? It's like, look cool, keep looking cool. Nobody saw that. Everything's fine. Yeah, so I mean, and I think part of our perception is skewed because, we have house cats and they seem like pretty fierce hunters, and then, all the nature documentaries show the successful kills because that's interesting. Mm-hmm. So you don't tend to see the unsuccessful kills as represented in the media as it actually is.
Yeah. But I think the fact that there's, well, I don't know, you would think for the things that birds are hunting, and he sort of brings this point up, right?
Like sloths?
Sure. Or other small primates or rodents, that they might be advantaged by being green, but they don't seem to have evolved that.
So, I mean, it must just not be enough of an advantage.
Yeah. Well, or there's just not enough of the like raw material there to turn that on.
Yeah, like the mutation, the necessary mutation just hasn't happened yet. Well, I think that's also why he said sloths just went the algal route, but I can guarantee being covered in a little bit of algae doesn't seem to make much of a difference when a harpy eagle spots the sloth.
Well, yeah.
The harpy eagle is still going to see the sloth, still going to swoop on the sloth.
Well, it's already spotted you now. It doesn't matter what color you are. But if you were green, and if you were algaic enough before this thing spotted you, maybe it would make a difference.
I also don't know if, like raptors, like raptorial birds, I don't know what their hunting success is.
I don't know.
Yeah. I know it's bad for cats in particular. Dogs aren't much better, but...
It seems pretty good for birds, because I've seen that myself many times.
And you've never seen a tiger bring down a kill.
Yeah.
Yeah, that's a fair comparison.
So there you go.
Yeah. Totally
I trust Charlie's observations over a lot of other hard data subjects.
I've seen lions take down a zebra. But that was pretty easy. There was like hundreds of zebras. They didn't even have to try that hard.
Plus, lions also coordinate.
I also saw them try to take down a water buffalo, and that did not work out. The dude just like stood pissed off and looked at them, and they like walked off like nothing happened. They were like, yeah, sorry, wrong neighborhood.
Yeah, size matters. Yeah. Being big and being in a herd, which, I mean, zebras are pretty big, and they're in pretty big herds, but they're not, at least in terms of mass, water buffalo's got some pounds on them.
But growing up on a lake, I saw ospreys take out fish all the time.
And ospreys are great because when an osprey catches a fish, it always points the fish facing forward as it flies back to its roost or den or whatever to increase its aerodynamic efficiency as it flies with the fish. So there's all these amazing photos of osprey flying with fish, and the fish looks like it's just freaking out because it's still alive, being flown by a bird to its death, but pointed in the right direction so it can at least see what's coming.
Yeah, that is...
Yeah, I saw a salmon fall in my backyard once, and it was still alive until my dog chomped it.
Oh man, I was really hoping you had some nice sashimi that night, but no, I guess so.
My dog did.
Dogs just don't appreciate sashimi the way it's meant to be tasted, though. Anyway, Charles?
Oh, yeah. I have a...
Also, John, sorry if Patrick just destroyed your point.
I think it's a really interesting question, though. Like,
yeah.
I wish I could see in all the spectra.
I dare you, Charlie, if you get a master's student to just assign them this project.
That'd be pretty terrible, though. Then, your microwave would be incredibly painful. Each time you cook some leftovers.
No, because the screen in your microwave door.
Yeah.
Already blocks the light coming out of the microwave light coming out of the microwave.
Well, everybody's LTE and Wi-Fi signals would be pretty annoying too.
Yeah, there'd be lots of other signals, but the microwave would not be one of them because that screen is an effective blocker of that particular wavelength of light.
Yes.
Don't remove the screen from your microwave door, people. It's bad news.
Yeah. And don't get vaccines. They cause autism.
Nope, Charlie.
I mean, the other way around. Yeah, that's right. Wait, how does it go?
I don't know. Are you voting for Jill Stein? Is that what's happening now?
Yeah.
Get vaccines, everybody, just for everything.
Yeah,
please. Get
Isn't
vaccines.
she the reddish-brown candidate?
No, she's the green candidate.
I get those two confused all the time.
But unfortunately, her evolving into a green state hasn't seemed to do much for her success. And also, if you meet friends who don't have vaccinations, bite them because that might transfer the vaccine over. We can't be sure, but it's worth trying.
It's what friends do for each other.
Yep. All
right, so I got a email from Les from Edmonton, Alberta. It's a whole nother country called Canada.
Oh, I think Americans are about to become very familiar with Canadian geography, Charlie.
Yeah. So he writes, "Hey there, PaleoPOWs. Les here. Just dropping a line to say hi that my fiance and I were enjoying a break from her school, her master's thesis and my night school upgrading. That must be a Canadian thing. In Jasper National Park in Alberta, Canada. While there, we decided to wander up the Columbia ice fields and have a boo. I hope that's a euphemism for a picnic. I'm not exactly sure what a boo is. A peak, maybe?
I mean, he also correctly spelled fiance, which seems like the benefits of a partly French education.
Yeah, he's got a French education. But I don't know what a boo is.
Well, you're my boo, Charlie.
Yeah, to have a boo. Anyways, I figured I'd send you a picture from there. Also, since my fiance did some field school in the area, we hiked up to a nice hidden alluvial fan and did science. By which I mean she looked at some rocks for some fossils, while I may have had to chase my shoe down a small glacial river. So here's a picture of said fan, and also the most evil and tiniest of rivers. So that river picture he sent is quite amazing. It's like running straight down a fault or something.
Yeah, it's crazy, isn't it? Like it's some sort of disconformity. Apparently, to have a boo just means to take a look.
Oh.
So, I had, yeah.
Yeah, that is.
I was hoping it was something more interesting than that. Like,
more French?
Yeah. Have a snoo-snoo.
Ooh. Oh, Futurama. The gift that keeps on giving. So I thought you would be into this, Charlie.
No, I definitely am. I mean, I want to check out some of these Canadian national parks. I've heard Banff is a wonderful place to visit, and Jasper is it's the Canadian Rockies, right?
Yeah.
So basically all the pictures look straight like out of Skyrim or something.
They do, yeah. It's very
amazing.
Skyrim-y. Yeah. We'll post these online because one of them has Les standing in front of a glacier wearing an OG Science Sort of t-shirt.
OG.
Yep.
Yeah,
that's pretty cool.
So stop by the website and have a boo.
Have a boo. Hey, Charlie, can you tell people what an alluvial fan is in case they don't know?
An alluvial fan is a fan-shaped feature made out of alluvium.
Which is river sediment, right?
Yeah, so when water is running down a hill, it has enough energy to pick up sediment and entrain that sediment. It will carry rocks and sand and other debris downhill. When it starts slowing down, when the hill gets less steep, it will deposit that sediment because it doesn't have enough energy to carry it any longer, so it'll fall out. When it falls out, it makes that part of the river floor slightly higher up. So then water, always seeking the downhill route, will change its course. So the river or stream will slightly move to the left or right, and then it will deposit its sediment there. And so the river actually travels back and forth like a, I don't know,
like a garden hose. Yeah.
Yeah.
It's got the...
That's the only thing that really does that.
A flagellum?
Well, I mean, that's basically the same phenomenon. You got water coming down a chute.
Or like the wacky, wavy, wild hand man in front of cell phone stores or something. So
that guy.
It'll flop back and forth and continue to deposit sediment, and then that will be the new high point. So the river will find a new low point, and it will go back and forth and end up depositing this convex surface, or it's a section of a cone basically, and so it's kind of fan shaped when you look at it. Man. And it's made out of stuff out of rivers, and that stuff is called alluvium. So it's an alluvial fan.
There's a lot going on in this picture of Les. He's wearing a Guinness hat also, which I appreciate. And then sort of behind him,
is that a wee heavy?
There's a
shillings.
He's got, I don't know if he did it or someone else has stacked a fair number of rocks in sort of a tower or cairn.
Yeah, there's a cairn back there. And then in the background, it looks like there's a bunch of people or something filming like Batman Returns or...
Or is that maybe it's
a sled team.
Yeah.
There's some pretty epic photos.
Yeah. All right.
Not Batman Returns, Batman Begins. The one where they fight on a glacier.
I mean, Batman Returns has the penguin, so there's also a lot of ice imagery.
That's really
in
more
Batman
of a
Returns.
southern hemisphere thing, though.
That's why I got confused.
You weren't wrong, Charlie.
Got my hemispheres mixed up again.
You just went with the Christopher Walken Batman instead of the Christopher Nolan.
But I guess they're not filming that anymore. Now they're doing Game of Thrones on glaciers, so they're filming Game of Thrones back there.
But they're doing it in Iceland,
There's
not
some
in Canada.
White Walkers. They should do it in Canada.
Totally.
I know Les has a fiance, so I'm not going to ask him to join the Night's Watch, but I'd appreciate him getting a Valyrian blade to defend us when the time comes.
Indeed.
Or at least some dragon glass.
Or just a dragon. That's going to work in the end.
I think it's going to take at least 3. Call me crazy. I'm guessing 3 dragons are going to be involved. I think that about wraps it up.
I think so, man.
Yeah, thanks for the photos, Les. Hope things are going well with your upgrading.
Yeah, it's always good to be upgrading.
I love it. If you want to see these photos, and you want to see Charlie's chart from the IPCC, what's the acronym for the Intergovernmental?
IPCC, Intergovernmental Panel for Climate Change.
Yeah, if you want to see all that and more, you can go to ScienceStore.com and look at the show notes for this episode, where you can also listen to the show. We have a little streaming button available, and download the show. There were people who were having trouble with the new website interface, being able to download the MP3s, for those of you who don't like to subscribe to an RSS feed and want to download each one manually like a crazy person. We've now made it possible for you to do that. It's in the show notes. It's not in the listen tab, so... but I've been putting it at the top of the show notes, so it should be very obvious, and you can go check it out and enjoy the new website because it's beautiful.
You can also sign up to have the show notes sent directly to you every week. If you get tired of going to the website, you can also give us a donation to help keep the show going. We'd appreciate that. And you can shop at Amazon.
Black Friday's coming up.
That's right.
Yep.
Shop at Amazon via our link. We get a little bit. Doesn't change the price for you. And it makes us very happy, and presumably you very happy when you get, whatever that shiny new thing is you just ordered off Amazon.
I'm probably going to order another microphone soon. Not a new or a different one, but I need, if I'm going to do in-person interviews, I need 2 of these.
Awesome.
Because I figured out a way to record 2 tracks on my computer when I'm not
That's
online.
Awesome.
So
plus you may need a mixing board or whatever it is.
Yeah, that's awesome. Your computer can be its own mixing board, or at least a 2-track mixer.
Yeah, at least a 2-track mixer with my 2 USB mics. But I also probably going to need to get a field recorder, Patrick, because I got press status at AGU, so I got to go.
Sounds good, man.
Press it up at AGU. This is still in the show, so everybody who's going to AGU, I'll be there, and if you want to talk about your science, come find me.
Do it.
Me and Miles Trey are going to be hanging out. I think Miles said we're going to record the Treyer and Haupt Science Happy Hour or something like that.
Nice.
So that'll be fun.
Cool.
Yeah.
Awesome.
And also is a big Game of Thrones nerd like we are, Charlie. So we had him on the show to talk about it. It's all coming up Westeros. It's always sunny in Westeros.
That's what they say.
At least except for the long night. That was the one time where it wasn't always sunny.
Yeah, I was going to say, I think it's more sunny in that other place.
Essos?
Yeah, the...
Dorne?
The city by the bay?
Yeah,
Dorne's still part of Westeros.
I was thinking more like, Menina or whatever it's called.
Marine?
I don't
Philadelphia?
Yeah, Marine's in Essos, though. Essos is the continent to the east of Westeros.
It's been a long time since I read these books because the dude quit writing books.
Well, we'll never quit podcasting, and go follow us on all of our social medias and keep sending in feedback so we keep having plenty of fodder for the PaleoPOW. And thank you for listening, and we will see you next time with a whole lot more science.
Sort of.
Visit sciencesortof.com for show notes, links to all the stories we talked about, and ways to interact with the hosts, guests, and other listeners. Science Sort of is brought to you by the Brachiolobe Media Network of podcasts, with audio engineering by Tim Dobbs of the Encyclopedia Brunch podcast. That's all for this week. See you next time on Science Sort of.
Unless we want to do like the whose line is it anyway of science. So we don't. What if we all took Alan Alda's improv for scientists course and then just started a science improv show, and that's the show?
I like it.
Give me the name of a field. Herpetology. Did I hear sedimentology?
Yeah,
that's
me today, I was like, what paper am I reading? Who is this about? Who wrote this?